Okay, guys, just like we talked about, again, this is Coach Scott, Purple Wave Chemistry. Today we're going to talk about chemical bonding. Chemical bonding. And this is from your summer work packet from the pre-AP site on cbhs.org. Please go and download it. If not, I can email you a copy. So let's talk about chemical bonding, right? And I'm not going to use that sheet. I'm going to use this one right here. So really, there's three types of chemical bonds that we're going to worry about. The first one is ionic bonding. Ionic bonding. The other one is covalent bonding. And I promise you my hands are not blue. That's just the light. Covalent bonding and metallic bonding. No, I don't have to really worry too much about metallic bonding. Okay, just remember sea of electrons. When we get to it, you'll hear it. We'll talk more about that. So ionic bonds involve a transfer, a stealing of electrons from one element to the other. All right. Cations are formed when an atom loses an electron and becomes more positive because it has more protons than electrons. Anions are negative ions, and these result from the gain of electrons because it has stolen an electron from another element, and now that it has more negative electrons than positive protons. So each of these elements are always trying to achieve a stable octet. A stable octet. What's an octet? There's eight electrons around um, the uh, the valence shell or the outer shell for the electrons. So metals, we're going to go down here now. So metals tend to become more, and I'm going to pause for a minute because these colors are way off. So we're just going to have to go with it. These are the colors, and that's okay because they are different, but my hands are not blue. But anyway, ionic compounds, the cations, positive, all right, are mostly metals. Okay, they're mostly metals. You should remember the periodic table. You go for the metalloids, that little line, and go to the left. Those are your metallic elements. Okay, and then of course your anions are negative because they have one more electron, and these are mostly nonmetals. All right, so some examples of some cations. All right, if I look at our periodic table, okay, just another little example, okay, anything to the left are metals, anything to the right are nonmetals, okay? So let's look at sodium, that's a good one. Sodium has one, straighten that up a little bit, has one valence electron because it's in group 1, sodium, okay, group 1. So it's got one valence electron. Well, it really doesn't like that electron, okay? Again, hopefully by now you need to know that these groups have something to do with their valence structure. So sodium has one valence electron, okay? That little dot right there means one valence electron. Would it be easier to get to lose that electron to get to 8 valence electrons or to gain 7 electrons? Of course, losing that electron would get it to a valence structure similar to neon. Okay. Well, you can't just lose an electron. Those positive protons are pulling in, keep those negative electrons there. But if something with more electronegativity, all right, the electronegativity would come and steal that electron, that makes it sort of happy. Let's look at another, see what color this is. Say with, let's think about chlorine. So chlorine, it has how many? 1, 2, 3, 4, 5, 6, 7. 7 valence electrons because it's in the group 17. It's got 7 valence electrons. Well, it's also pretty close to fluorine, so the electronegativity, we'll call that as strong. The electronegativity for sodium is weak. So what happens, guys, is that the chlorine comes near there and it'll steal that electron and put it over here. So now chlorine, okay, has 8 valence electrons. Sodium, we're going to leave it blank. But sodium, the sodium ion, also has 8 valence electrons because it lost that one. And it's got the 8 from structure like neon, right? But what's the charge? What are the charges of these two ions? Well, let's see. Sodium has an atomic number of 11. Okay, it lost an electron. We'll call that the Z number now. It lost the 1 electron, so now it has 10. So these are negative and these are positive. Now it has a positive 1 charge. So now this neon, sodium, Na, now has a cation with a +1 charge. Chlorine, which has a atomic number of 17, Z number of 17, okay, now has 1 more electron. We'll do this, electrons. So now it has 18 electrons. Well, that means, if I add those two together, that means I have 1 extra electron. -1. So now this has a -1 charge. Okay, so this +1 and -1 charge, what are they going to do? Well, they're going to come together, and they're going to come in, and they're going to get close together, and that's the bond. So now I could write this NaCl like this, +1, and they're going to be attracted to that -1 charge. Let me move this up a little bit. Okay. And now that is what we call an ionic bond. And that's the strongest bond of what we're talking about here. It's hard to break. Okay. Very hard to break. Which leads to ionic compounds are brittle. They're what's it called? They're a cube of a cubic structure. They're a crystal because of this strong ionic bond. Let's look at another one real quick. And we'll flip this around. So I got white space here. So let's look at, like, say, magnesium. So magnesium is in, let's see, group 2, right there. All right. So that means it's got what? It's got 2 valence electrons. Let's put those out there. Then let's look at chlorine again. Chlorine, we know now. Let me use a different color. chlorine has how many valence electrons? Well, it has 7. 1, 2, 3, 4, 5, 6, 7. So this is going to have this will have a little weaker or a little stronger electronegativity, but it's still weak. Still very metallic. So the En on this is weak. And on chlorine, well, that electronegativity is strong. So that one chlorine will steal that electron. So that's got a -1 charge now. We go through the math again, but I think you understood it there. Now this species now has a +1 charge. It's still got one extra electron in the valence shell. But what if there was another chlorine? And there probably is floating around there. Well, that magnesium, right, it's got a little weaker electronegativity because there's more, well, it's a little stronger. There's more, actually it's ionization energy. There's more pull for that extra electron or the extra proton to keep that one electron in the valence shell there. But this electronegativity is still strong enough to pull that one away. So it pulls it away. So now this chlorine is also now a anion. So now we've got one magnesium and 2 Cls. Okay. So we started out with magnesium with 2 electrons there. Chlorine with 2 chlorines with 7. The 2 chlorines will grab those 2 electrons, right? So now we've got an ionic formula unit of MgCl2. And what's happening is the electrostatic charges of this of -1, -1, -1, and that +2, they're being pulled together electrostatically. So now you've got a very strong bond now. So we would call this MgCl2 because those two things are holding it together. Okay, well that's enough for today, and that's just the beginning of ionic bonding. Our next video, we're going to go into covalent bonding because it's pretty simple. And that way we can also talk about polyatomic ions. Okay? Polyatomic ions. Then we'll come back and talk about how they affect ionic bonding. Another little fact to know is you won't find NaCl all by itself. That's why we don't call these molecules. We call these formula units. You'll find these in a big structure, called a cube, right, or a crystal if they're solid, all right. If they break down in water and they're soluble, you'll have one magnesium and 2 chlorine ions floating around in there. In NaCl, you'll have one sodium ion attracted to one chlorine ion, but there's a bunch of them if it's a solid. You won't find just one discrete component of NaCl. All right? Okay, guys, that's enough for today. This is Coach Scott saying have a great summer, have a great day today, and don't forget, email me. We can get one on one if possible. So, anyway, that's all we got for today. Have a great one.